Hey everybody, this is Mr. Schultz here with you, and we're going to be taking a look at lesson 822. How can I write it in simpler form? Exponent rules. So we've talked about these a couple of days ago, the day before scientific notation, which is what we did yesterday. In the previous lesson, you expanded expressions written with exponents into factored form and then rewrote them into a simpler form, or in simpler form. You looked at ways to rewrite very large numbers in scientific notation. So the first part here was 2 days ago. We had things that we had like something like 2 to the third times by 2 to the fourth, and we wrote them into factored form. So we said 2 times 2 times 2 for 2 to the third. We had our second one, which was times by 2 times by 2 times by 2 times by 2, and then we called that whole thing equal to 2 to the 7th power. And then our second day, we looked at things in scientific notation. In this lesson, we're going to continue on this trail here, and ways to rewrite expressions using exponents, and we'll use the questions below to help our discussion. So, what part of the expression is being raised to a power? What are the factors? How can we rewrite the expression to have fewer terms? Let's start out by reviewing some of these concepts here. So the first one, in question 8-59, it says this: rewrite each expression below in a simpler form. So in part A, I've got 10 to the second times by x to the third times by 10 times by y. Take a second, pause the video here, see what you remember about this, and then we'll bring it back in. All right, so how we looked at this before is we wrote each thing out into factored form, and then we combine it at the end. So 10 to the second would be 10 times by 10, saying 10 multiply itself 2 times. X to the third is just x times by x times by x. There's 3 x's, x raised to the third power. I've got this 10 that stays the same, and I've got this y that stays the same because both these are to the first power. So now I can just combine the things that are the same. Well, I've got 1, 2, 3 10s, so I've got 10 to the third power. I still have my 3 x's, so I've got x to the third power, and I've got just a single y, so this is y, or y to the first power. If you wrote that one, I probably wouldn't mark it wrong, but you just don't have to write that. It is not necessary. So then, we're going to do a similar type of thing in part B here. So, take a second, pause the video, write this out in factored form, and then get your final. Okay, so here we have our problem in factored form. So I've got 20 to the third, so I've got 3 20s there. I've got 20 to the eighth, so I've got 8 20s here. So now to write it in the simplest form, I just need to combine all of these 20s into one single statement, which is going to be 20 raised to the 11th power because there's 11 20s there. So you might notice or remember that our shortcut was when I'm multiplying two things that have the same base. So the base is the big number, so 20 and 20. I can just add up the exponents. 3 plus 8 gave me 11, and my base stays the same. So we can use that same concept here on part C and just say I just need to get things that have the same base. So like x and x have the same base, and they're being multiplied, so I just can add up these two numbers. So I'm going to be left with x, 2 plus 3 is raised to the 5th. Now my next base, y, well I don't see another y. So I can just leave that as y squared. Done. Now my last thing here, z to the second, z to the 5th, works the same way as the x did because it's multiplying. So 2 plus 5, I ended up with z to the 7th power there. So just basically adding up the exponents there. So x to the second plus 3. I've got that, what color to use? Blue. Y to the second, that stayed the same. And then I've got z to the second plus 5, and that's where you're getting your total or your final answer of x to the 5th times by y to the second times by z to the 7th. Let's take a look at the next problem. Now in question 8-60 here, it's got this stoplight, which means be careful here. There is something that is wrong about this. So Aaron wants to rewrite the expression 5 to the second times by x to the second times by 5 to the fourth times by x to the third in simpler form. She started by expanding the expression like this. So she expanded it out, and she used these plus signs here, and then she simplified everything down to this. Do you agree with her work so far? Take a second, pause the video, see what you think. Do you agree with her work so far? Okay, so what I came up with is I said, no, in the first expression, in this top one here, there are no addition signs. I don't see anything here that says plus. Everything should just be multiplied. But in Aaron's, she started to add these plus signs. Well, everything should be multiplied. There are no addition signs in the original expression. So to solve it, we would just need to find the bases that are the same and then add the exponents, not the bases. So here, I would go through and I could do this and say, okay, 5 to the second, that's a 5 base, and 5 to the fourth, that's a 5 base. So I just need to say 5 to the second, add that fourth, and get that whole number there. And then I just need to multiply that by my second base, which is x to the second, x to the third. So I'm going to say x to the second plus 3, and I'm going to get my final answer here of 5 raised to the 6th power and x raised to the 5th power. So 5 raised to the 6th power times by x raised to the 5th power should be the solution that Aaron is looking for. Okay, so now we've gone through and kind of reviewed these concepts that we did the last 2 days. Let's start to take a look at some new concepts here in the next problem. So in problem 8-61, it says, when a number is raised to a power and then raised to a power again, the result follows a consistent pattern. Complete the table below on this lesson resource page. The lesson resource page is literally just this table here. So if you don't have this, it's fairly easy to just write down and make, or copy down and complete it on your own paper, like I just said. Expand each expression into factored form, then rewrite it with new exponents as shown in the example. So here's our example, and we just want to rewrite these things and then write it in the simplified exponent form. So start off by taking a look at this here. So original form is 5 raised to the 2nd power, but then that is in a parentheses and raised to the 5th. So it's like saying I've got 5 groups of this whole thing here. Well, 5 to the 2nd, that's just 5 times by 5. So here I've got 1, 2, 3, 4, 5 groups of 5 times by 5. So what this really is in total, I've got a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 5s, which is how I'm getting that simplified form of 5 to the 10th. Okay, so let's take a look at the next one here then. So now I've got 2 to the 2nd. We'll start with inside of the parentheses. That's just 2 times by 2. But I've got 4 groupings of that. So I need to get 4 groupings of 2 times by 2. So here's my 4 groupings of 2 times by 2, which in reality just comes away saying I've got 1, 2, 3, 4, 5, 6, 7, 8 2s. So this is really 2 raised to the 8th power. Pause the video here for a second and remember what they said in the question. Result follows a consistent pattern. What do you see is the pattern here happening from 2 raised to the 2nd raised to the 4th, or 5 raised to the 2nd raised to the 5th. What's producing our consistent pattern result here? Pause the video and see what you think. Okay, now it's time to check your idea here. So let's see what we come up with here. So we've got 3 raised to the 7th power raised to the 2nd. So if I were to rewrite that in factored form again, so 3 raised to the 7th, I've got 7 3s here, but I've got 2 groups of those 7 3s. So 7 3s and 7 3s, so I'd have a total of 3 to the 14th power. So did your idea work? Did your pattern work? Hopefully what you were seeing here is this. 2 times by 5 is 10. 2 times by 4 is 8. 7 times by 2 is 14. So when you've got a power being raised to a power, then you multiply. In the previous examples, the difference here is this. When I have something like this, I am adding the bases because I've got 2 bases being multiplied here. So this was 3 to the 6th. But when I've got 3 being raised to the 4th power, that equals 3 to the 8th because I've got a power raised to a power, not just a straight multiplication. So there is the difference there. So using this rule, let's see if we can figure this out without having to go into expanded form here for these next two. So I've got x to the third being raised to the fifth. Well, that should just be 3 times by 5. So I'd end up with x to the 15th. If you want to see the expanded form, it looks like this. I've got 5 groups of x times by x times by x. So 1, 2, 3, 4, 5 makes x to the 15th. Now we've got this new one, though. Now we've got 2 things on the inside here. So let's break this down now. Well, in theory, this is still x raised to the third, y to the second. So that's going to look like this. So inside the parentheses, I've got x times by x times by x. That's x to the third. And I've got y to the second, y times by y. But I've got 2 groups of that. So that's going to look like this. So there are my 2 groups. So again, just like the previous problems, I just need to add these up. Well, I've got 1, 2, 3, 4, 5, 6 x's. So I'm going to call this x to the 6th power. And I've got 1, 2, 3, 4 y's. So that's going to be y to the 4th power. So our rule still holds even if there's multiple things on the inside. I'm just saying 3 times by 2 is 6. 2 times by 2 is 4. I just need to apply it to both of these pieces, kind of like our distributive property rule. So make sure to apply it to both of those pieces there. Before we move on, let's summarize this just one more time here on the next page with problems A and B. So here on problem A, it says work with your team to describe the pattern between the exponents in the original form and the exponents in the simplified form. Well, we just said that that was just if we had something like 8 to the second being raised to the fourth, we were just multiplying the exponents. That was equal to 8 to the second times by 4. So it's equal to 8 to the 8th power. So we multiply the exponents when they're raised to a power. Multiply when raised to a power. When raised to a power. And on the previous slide I said this, but we add when it's just bases being multiplied. So then our next problem, B, says visualize 20 to the third to the 8th written in factored form. Okay, so I'd have 3 groups of 20. So I'd have 20 times by 20 times by 20, and then I have 8 groups of that. What is being multiplied? That is, what is the base? Well, 20 is the base. And it's got 3 20s being multiplied 8 times, so I'd have a grand total of 24 20s there. So, which is 3 times by 8. 20 raised to the 24th power. Okay, let's take a look at the next one, which is 8-63. We are going to skip 8-62. This one says on 8-63, Heidi is trying to rewrite 2 expressions below. In parentheses, 2 times by x, close the parentheses, raised to the third, and 2 times by x raised to the third. So the one has parentheses, the other one does not. And she wonders, are these 2 ways of writing the same thing, or do they mean something different? So rewrite in parentheses 2 times by x, close the parentheses, to the third, by expanding and then simplifying which part is being raised to the third power. Well, remember from our previous example, we were saying that we have 3 groups of this. So I'd have 2x, 2x, close the parentheses here, and 2x. So then, again, we just need to count this up. 1, 2, 3, 2, so 2 raised to the third, and I'd have 1, 2, 3 of the x's, so I'd have x raised to the third. Okay, so what part is being raised to the third power? Both the 2 and the x. Both 2 and x. In part B, it says, Heidi thinks 2 times by x to the third is the same as 2 times by x to the third. Show that she is correct by expanding the expression. Okay, well, I'd have x to the third power. So I'd have x times by x times by x. And then I just have this 2. So the exponent in this case is not working on the 2. It's only working on the x. In our previous one in part A, it was working on both pieces because of the parentheses. This one does not have a parentheses, so she's correct. It's 2 times by x times by x times by x, which is x to the third. So we can conclude in part C, in parentheses, 2 times by x raised to the third and 2 times by x raised to the third, they are not the same. The parentheses here makes a difference. It's saying what's happening with that 3. Is that 3 applying to both of the bases there? Or, like in the second one, 2 times by x to the third, the to the third is only working on the one base there instead of on both of the bases. And that's a whole bunch of everything we have for today. Have a good rest of your day.